Hello friends, this is Patel Pass and welcome to my channel. Here you can see this is a bullet, this is a pond and this is the wall. We are going to do bullet explicit dynamic analysis in ANSYS workbench. Okay. So you can see it here what kinds of the result we will get at here in the total deformation. Okay, when the bullet is strike to it. So what kinds of the result we will get, you can see it here in the better way. Okay, this is how the pond is totally destroyed by this bullet. Okay, so how to do this analysis we will see step by step. First we have to click on this explicit dynamic command, on double click on it. First we have to select, before starting analysis we have to select the first the material for the wall, bullet as well as for the pond. You should click on engineering data, then go for general material. Then you can find out material, different kinds of the material. We select aluminum, stainless steel for bullet and polyethylene for wall and pond. Why I select the polyethylene? Because the polyethylene is a very ductile and the soft material, so we can see better dynamic analysis in bullet. Here I will not draw any kinds of the part at here. I just import the parts from external geometry which I made in SolidWorks software. So how to import the part from different software, you should watch my first video. Here you can see this is the bullet, this is the two wall and this is the pond. Bullet strike to this wall and then it's a go for the pond. Okay, then back to the main page, click on model. We will do the setup, solution and we will also find out the result in this model. Here also first we have to select the material for these three things. In engineering data we just only select the material, we didn't apply the material for these all three things. So we have to apply the material and we can apply the material from this geometry. Okay, click on the wall 2, so you find out all the properties of this wall 2. Here you can find out the material assignment. To assign the material for the wall we apply polyethylene. For wall, this wall I apply again polyethylene. Part 2 means this bullet. Okay, so I apply for stainless steel. In part 1, first I apply the aluminum, then I go for the polyethylene. Then apply mesh. In the mesh you can find out also the properties of the mesh. Here you find out the sizing. In sizing, this command is very important for us. Use advanced size function. When the part is too complex and sometime we didn't get or we do not get any kinds of the solution by the mesh, so we have to apply the proximity and curvature. It can provide the fine mesh and also we can add in relevant center fine. So by the fine we can get the fine meshing. By this we can get the huge amounts of or the fine analysis at here. Okay, our part is not that much kinds of the complex, so I just off this use advanced size function and relevant center is code, so it take the less time. When I apply the proximity and curvature, so it will take the huge amounts of the time to generate a mesh. The mesh is ready. Okay, and you have to ensure about this right click. The right click is done, then it will okay. Then go for the analysis setting. You find out at here the question mark, so you have to provide it here. I just provide the end time 1 second. Then we have to select, I'm going to select the fixed support to this bottom face. If I didn't apply the fixed support at here, so when this bullet will strike to it here, then it will go with the bullet this point. Okay, so that's why I applied here. I apply the fixed support for this wall also at the bottom side, just only the bottom side. I just select the face. You have to ensure about, because sometimes you select the body also, so and I will also provide the fixed support for this wall, and I also provide the displacement for this wall also. First I suppress this displacement, and after that I suppress this fixed support which I applied it here. And in the displacement you can see the x direction in this direction, but I have to apply uh, free, this x direction free, because this bullet strike to this wall and this in the axis of x. I have to free this axis, and another y and z axis I have to zero, means no free in this axis. It just move, it just displace in the x axis. Okay, so first I suppress this fixed support. Okay, means this is not fixed. Okay, it will free in x direction. So when the strike, when the bullet strikes, so what kinds of the result we will get, we will see. Then go for the solution. Here you can apply the total deformation. Here you can also apply the 1 minus stress, 1 minus strain, and here you apply the 1 minus stress. Okay. Here I also apply the directional deformation, then go for the swap. Okay, sorry. Here I didn't apply any velocity for this bullet, because without velocity it cannot be moved. Okay, I apply the velocity in x direction because x direction is this, so I apply the minus velocity minus 2000 meter per second, means 2 kilometer per second. Okay, 2 kilometer per second, so it's huge amounts of the velocity. Then go for the solution. Here you can see this error is generated at here because I didn't apply the velocity. So sometimes you forgot to apply, so you get the error, and then go for the solution. Okay, our solution is ready. In total deformation, you can see when I apply the 2 km per second velocity for the bullet, so you can see in the better way. Look at this here. What kinds of the damage we get at here in the pond also. For the pond, I applied at here the aluminum alloy, so that's why the deformation is less. I'm going to hide this one so we can see better. Equivalent stress, we will see equivalent stress at here. This blue region show the 2 point, here you can see the 2.3 Pascal. 2.3 into 10 raised to 10. E means 10 raised to 10. Here you can find out the E means 10 raised to 10 Pascal stress is generated at here. And for the directional deformation, you can see, I'm gonna to show this one. So in the directional deformation, you can find out in the better way. Also, you can decrease the speed of this. Here the speed is too much high, that's why it's a strike in very high way. What kinds of the damage we get at here? So these kinds of the damage we get in actual way also when the bullet is strike to in this manner. I told you first I apply the displacement at here, and then I'm gonna to suppress this displacement, and I apply the fixed support at here for this edge. So what kinds of the result we will get at here, you can see. Here you can see the displacement when I apply the displacement for this face is different. Okay, you can see it here, and you can see also the how or the bullet is deformed. Okay, look at this edge of our bullet, because it's a strike to the aluminum pond, so that's why our the bullet is deformed like that. So first you can see, you find out the maximum stress at here, or the bullet is not inside the pond, it's broken at here. Look at this, the tip of the bullet. First is first our bullet tip is in the good manner, but after the strike of this aluminum pond, it's broken totally. You can see it here, the tip of before strike to the pond, and after the strike of pond. Okay, it's a broken or it's a damaged totally. So here for the pond I apply the material polyethylene. Okay, so then after what kinds of the result we will get at here, we will see. Our result is ready. Look at this. How much velocity? 2000 sorry, 2 kilometer per second velocity. So what kinds of the result we will get at here? It's a totally damaged. We find out the totally damaged part at here. The pond is totally damaged. Okay, and equivalent stress, you find out the stress at here. It's a huge amount of the stress, 6.710 is to 9 Pascal. Here you find out also the total deformation at here. Look at this huge amounts of the damage is generated at here. And you can also save the animation at here, export video file. You also save this animation at here. Thank you so much, and please share and subscribe my channel. Thanks a lot.